All right, so yesterday we learned a little bit about Pythagorean Theorem and Pythagoras and how Egyptian builders used this theorem to find perfect squares. There's a lot of really good information. Take your backpack off, stay a while. Okay, so we can also, and we did some problems with right triangles, and we did some problems where we just had A, B, and C, and we had to find the missing side. Okay, and there was a lot of information that I gave you yesterday that you could use today. Okay, so today we're going to do a little bit of graphing, and this should be a lot simpler to do than yesterday's. Okay, this is going to be easier. Well, I don't know, because some of you really struggle with graphing. Okay, so what we're going to do is we're going to go ahead and we're going to plot these points, right? So we have 1, 3, and 4, 7. So I'm going to go and I'm going to zoom in on this one because I can. And I'm going to go to 1, x is 1, and y is 3. And I'm going to put my point there. Bless you. Okay, and then I'm going to go to 4, 7. Okay, so I'm going to go to 4 and then 7. Okay, and there I have 2 points. Okay, so I'm going to take my straight edge and I'm going to connect this line. Okay, so as you can tell, this line is a diagonal, right? So I can't just count units or boxes to figure out how long that distance is. But I can complete my triangle. So if I do this, I now have a right triangle. Am I right? Okay. So this is my right triangle. Here's my box. So this is going to be side C, right? I'm going to go ahead and just label it as C. I'm going to take this short side. I'm going to call it A. And I'm going to take this longer side and I'm going to call it B. Huh? I found my 2 points, right? You said it was easy, right? And then I just took my line and I drew it down to where they would meet. So now I have a right triangle. You're just extending your lines out. Not yet. All right, so now I know. So I have a side A, and I can measure this unit. So I have 1, 2, 3. So side A is equal to 3 units, right? Because I can count from here to there. Side B is 1, 2, 3, 4. So B is equal to 4. Easy peasy lemon squeezy so far, right? So I'm going to take that information and I'm going to put it into my Pythagorean theorem. Okay, so Pythagoras' theorem says a squared plus b squared is going to equal c squared. Okay, so I know that a is 3, so 3 squared. And I know that b is 4, so b squared. But I don't know what c is, so I don't know what c squared is. So this is when our cards come in handy, right? So what is 3 squared? 3 squared is what? Okay. And what is 4 squared? And that's going to equal c squared. Yes? So far, so good? What's 9 plus 16? What's 9 plus 16? 25. So 25 is equal to c squared. And this is nothing that we haven't already done, right? So I don't want to know what c squared is. I want to know what c is. So when I take the root, remember, it's a scale, and I have to do it to both sides. Isaiah, over here, please. So when I take the root, this root cancels with that one. So that leaves me just c. And I know, because I wrote it down on my cards here, what is the square root of 25? 5. So I know that the square root of 25 is 5. And c is equal to 5. Right? Easy peasy, right? So first you graph it. Okay? And then you substitute those numbers into the equation and you solve it. My triangle. From here to here, I went 1, 2, 3. That's 3. Isaiah, you watching? From here to here, I counted 1, 2, 3, 4. Okay? What line? Where did I get this 9? What's 3 squared? Camila, I'm talking to you. What's 3 squared? No, it's 9. Do you have your card? Did you find your card? What's 3 squared? 9. That's where I got the 9. What's 4 squared? That's the 16. Okay? Got it? Yes? It's super easy, right? Let's do one more. Super, super easy, okay? So let's go ahead and look at number 3. Zoom out a bit. Let's look at number 3. I've got -2, -5. So x is -2. I'm going to go left 2, down 5. And there's my first point. Okay, then I've got 3, -8. So x is 3, so I'm going to go right 3 and down 8. All right, and then I take my straight edge, lost it, and I'm going to draw a line from my 2 points, a line from here to here. Okay, so it's a diagonal line, which tells me that this is going to be side C. Now I can either complete my triangle this way or this way. It does not matter. It's going to be the same distance either way. I'm just going to go ahead and draw down this way. Okay, so this is going to be side C, this will be side A, and this will be side B. So let's go ahead and see what A is equal to. A is equal to 1, 2, 3. Again, so A is 3. B is equal to 1, 2, 3, 4, 5. So B equals 5. Okay. So I'm going to go ahead and I'm going to take my sheet of paper here, zoom out a bit, and I'm going to say, so here's number 3. Again, my formula is a squared plus b squared is equal to c squared. What do I know a is equal to? 3. So it's going to be 3 squared. What do I know b is equal to? So it's going to be 5 squared. And that's going to equal c squared, because that's what I'm trying to find out. What is the length of c? We know from our previous that 3 squared is 9, and we know from our previous that 5 squared is 25. Right? Making sense so far? Okay, what's 9 plus 25? 34. Okay, here's where it gets tricky. Okay, I still need to take my square root to solve just c. My roots cancel. I'm also going to take the square root of 34. I'm looking at my list here, and 34 is not a perfect square, right? It's between 25 and 36, and it's much closer to 36, right? So my root is going to be approximately, so c is going to be approximately, it's not going to be exact, more than 5. We said it's closer to 36, so it's going to be above 5.5, and I'm going to say it's about 5.7. I'm going to take a guess. I should be close. Let's see, 5.7 squared is 32.49. That's really close to 34. Could I try 5.8 just to see? That's 33. That's even closer. So if you're within 1 or 2, we're good, okay? 5.7, 5.8, maybe even 5.9. I think 5.9 might go over. Just don't go over, okay? Understand? So this is just the in-between, just like we did with the square roots last chapter. You're fine, yeah. Yeah, just get close, all right? Because it's approximate. It's not equal. They're squigglies. So it's an approximate answer. Okay, here we got an exact answer for number 1, and number 3 gave us an approximate answer. But either one, okay, as long as you're within 2. Question?
5.9 is 5.9 is 34.
It's 34.01, right? So you went over by 0.1. Don't go over. Its price is right here, okay? We want to get as close as we can without going over. And if you're within 1 or 2 decimal points, you're going to be okay with me. All right? Got it? Frank, you understand? You went over, right? 34.01 is more than 34, right?
Was it 8.1 part?
Huh?
That 8.1?
That point, well, yeah. It pushed it over. Okay, it's more than 34.
Okay, yeah.
All right? Any questions? You only have 10 problems to do and the rest of the period to do it in. Ready?